Hi, my dear students. My name is M.NARESH. So, as we are having a pandemic days of COVID-19, so many students are facing the problem with mathematics. So many students are making phone call to me. They're asking doubts to me. So yeah, I have started this program. This program name is Brain Booster Program. Brain Booster of Mathematics. So as this program daily, I will teach a topic, a shortcut technique. It may be a shortcut technique. It may be topic of your textbook. A clear explanation, step-by-step explanation I am going to give now. Okay. So yesterday, many students have made call to me and they have asked about the H.C.F, highest common factor, and the shortcut method. They asked me to explain. That's why today I'm going to explain about the highest common factor. Let's see the what is highest common factor. Now see H.C.F. What is H.C.F? H.C.F is nothing but it is the largest positive integer which divides two or more given numbers without remainder. Without remainder means with remainder 0. H.C.F is nothing but it's the largest positive integer which divides two or more given numbers. Means the H.C.F is the common factor of all given numbers. All given numbers. So it divides each of number without remainder, means remainder must be 0. As we know that the numbers are two, whatever the given numbers may have the more common numbers, common divisors, common factors. It may be have two common factors, maybe have four common factors. But which one we can consider as HCF here means the largest common factor is known as highest common factor or greatest common divisor. The other name of highest common factor is the greatest common divisor or the greatest common factor. That's why we are calling them as HCF or GCD or GC or HCD. These are the names of HCF. For example, I'm taking 15, 15 and 20. The 15 and 20. These are the two digits, two numbers. We need to find the HCF. And usually, generally we take we divide 20 with 15. Okay, we divide 20 with 15, and we can find it. For example, 15 ones are 15, and remainder is 5. Again, with 5, we need to divide 15. 5 threes are 15. So remainder is 0. So the year we consider 5 as here we consider 5 as HCD. But there is one shortcut method. See, only just no need of dividing here. The shortcut method is just to find the difference of 15 and 20. The difference of 15 and 20. So 20 minus 15 is equal to 5. So only just we need to check this difference whether it is factor of 15 and 20 or not. We have to see that. Simple. Only just we have to see that whatever we got the difference must be the factor of 15 and 20. If it is factor, no doubt it compulsory, it must be the GCD of the given numbers. So already we have proven much more sense. So easily we can find by find the difference of the given two numbers. Let us take one more example. One more example for GCD. For example, I am taking 18, 32. 18 comma 32. We need to find the GCD of this 18 comma 32. Now let's see, as we discussed that, let us find the difference of 32 and 18. It is nothing but 40. But see, if you see that 14 is not a factor of 32 and also 18, then in this case, what we need to do means only just let us take the factors of 14, just factorize it. And what do you get? 2 and 7, and one more factor 14, and one more factor 1. These are the factors of 14. In this, we need to take the least factor of 14. So that is to be considered as the GCD of 32 comma 18. It's simple. What's the point? Only in this case is if the difference is not a factor of given two integers, then here we need to factorize the difference, and we need to select which is the least common factor. That common factor must be 32 and 18. Must be factor to the 32 and 18. For example, in the given, we have got the years, for example, we have got here 4 digits here. In these 4 factors of 14, none of them is factor of 32 and 18 then. So finally, we need to take 1 as a GCD. Got the point? So that's why, as we have got the 2 is the common factor of 32 and 18, here 2 be considered as GCD. Got the point? Now let us take one more example now. One more example. 22 and 17 I am taking, for example, 22 and 17. What is the difference between 22 and 17? It is 5. It is 5. See, as we have discussed that 5 is not a factor of 5 is not a factor of either 22 and 17. So as we have said, I have said that let us take the factors of 5 and 5 comma 1. Yeah, yeah, 5 is not a factor of 22 and 17. It is not a common factor of 22 and 17. That's why the final answer is 1. So 1 is the GCD of 22 and 17. Finish. Got the point? So like this, we can find the H.C.F of 2-digit number by using this shortcut technique. Is it applicable for 3 digits and 4 digits also? Yes, it is applicable for 3-digit number and 4-digit number also. Then how can we find the HCF or GCD of 3 digits or 4 digits of number? Let's see now. Let us take 3 numbers now. Say, I'm taking 15, 22, and I'm taking 31. So let us take these two differences. The difference of 22 and 15 is 7, and the difference of 22 and 31 is nothing but 9, and the difference of 31 and 15, 16. So here we have got the 3 numbers, 7 and 9 and 16. In this, we need to take the smallest number. What is it? The smallest number should be taken. So in this 7 and 9 and 16, the smallest number is 7. And we need to check it whether the 7 is the common factor of 15, 22, and 31 or we need to see that. It is not a common factor of any numbers. So we need to take the factorize as it is prime number. So 7 comma 1, it is only it has the 2 factors, 1 and itself. So as 7 is not a factor of any of this number, then 1 is considered the GCD of 15, 22, and 31. Simple. Only just we need to find the difference of 22 and 15 and 31 and 22. In very simple way, we can find this GCD. So like this, it can be applied for 4-digit numbers also. It can be applied for 4-digit numbers also. Let us see the one more problem. Let us take the 4 numbers now. Sorry, 22, 13, 80, and 71. Now let's see that the difference. Let us find the difference of any each two numbers now. I'm finding the difference of 22 and 13 is 9. The difference of 13 and 18 is 67. And the difference of 80 and 71 is 9. And the difference of 71 and 22 is approximately 49. So let's see now. We have got the 4 digits again: 9, 67, 9, and 49. As I said that the least number is 9. So as 9 is a factor of any of this number, so that's why let us take the factors of this one and 3 and 9 and 1. So the least one is 3, but here and 1 also there is the least one. So let us see that 3 and 9, but none of these three are, there's 3 comma 9, both are factors of these 4 numbers. That's why the final answer is 1. So our 1 is the GCD of these 4 digits. Got it, my dear students? So this is the amazing shortcut technique to find the greatest common divisor of or highest common factor of the given digits. So practice it. If you have any doubts, please you can message me in the WhatsApp. You can send the message. You can ask me any doubt in the next live session. I will clarify the doubt. Thank you very much. Hi, my friends and students. Welcome to this lesson. In this lesson, we are going to learn amazing facts about LCM and what is the exact definition of LCM. What is the exact definition? What is the formal definition of LCM? And I am going to reveal all the secret tricks, all the secret techniques to find the LCM. I'm going to reveal in this class now. That's why. So let us learn. Let us go into this lesson. See, first, what is LCM? LCM is nothing but, as you know, that LCM is nothing but least common multiple. L for least and C for common and M for multiple. And also lowest common multiple also. In other words, we can say that. There is no doubt. Everyone knows. LCM stands for least common multiple. Then what is LCM? What is LCM? Every student is making mistake in form a definition to the LCM. Everyone says that least common multiple. What is exact definition of LCM? Let's see that. So today you'll get the clarity about the LCM now. Then LCM is nothing but, see, it is the least natural number which is the multiple of given numbers. The least natural number which is multiple of given numbers. For example, in a particular problem, if you want to find LCM of 2 or more numbers, that LCM would be the very least common multiples of given numbers. Got the point? LCM is nothing but it is the least common number, least natural number, which is a multiple of given numbers. Or nothing but, in other words also we can say the definition, the least natural number which is divisible by each of given numbers. Got the point? Let us see. Let us check this formula. Let us check this definition by taking one example now. Okay, I'm taking the two numbers. Okay, that two numbers, how we can find the LCM, then what is the role of the LCM, then we'll see that. Okay, least common multiple. See, I'm taking the two numbers, example 2 comma 8. 2 comma 8. I'm taking the two numbers that are 2 comma 8. Got the point? And also, I am taking these tables. I don't mention here the direct method to find the LCM. Got the point? What is LCM? Let us learn that. In the clear definition, the definition, how we can apply this. Why? What is the role of the LCM? We can learn this. Let's see that. I'm taking the two table. You know, everyone is perfect two table. Okay, and I'm taking the 8 table also. 2 table and 8 table. Only just see, we are going to learn. We are going to learn the common definition. What is the formal definition? How can we apply to the numbers? Easily we can understand that. Now I am going to see the, let's see the once again least common multiple. Okay, two table, 2 1s are 2, 2 2s are 4, and 8 1s 8. Here see, the multiple of 8 comes from, starts from 8. That's why 8 must be the 8 must be the common multiple of given numbers. Other point. And there were one more number also, and 16 one more number, and here also 16. Other point. So we know that nothing but all even numbers are multiples of 2. So that's why these are all numbers of multiples of 8 are the multiples of 2. For example, if you take the 24, 24 means 2, 12 the 24. 2, 16 to 32. That's why every even number is a multiple of 2. What's the point? Okay. So here I am writing this one. See, the 8, comma, and the 16, comma, and 24, so on. These three are the three common multiples, first common multiples here. In these common multiples, we need to state, see the definition, see the least natural number which is divisible by each of given number. Yeah, we have taken two numbers 2 comma 8. Only just see, as these three are 18 and 16 and 24, these three are the numbers. These are all divisible by 2 and 8, each and given number. But here, what is the LCM means? Here, the least one only LCM. Got the point? I think you have got idea about LCM now. Okay, only we need to take least. These three are the common multiples. Among them, we need to select least one. We need to consider the least natural number as LCM of the given numbers. Got the point? For example, I'm taking one more thing. See, and one more problem. For example, and I'm taking 12 comma 4. 12 comma 4. For example, 12 table. I'm writing the multiples of 12. 12. Sorry, and 24, and 12 to the 36, and 12 fours 48, and so on. I'm writing here multiples of 4 3 is 12, and 4 4 is 16, so on, and 4 5 is 20, and 4 6 is 24, so on. Here I have written some of the multiples here. Now let's take common multiples now. Let's take common multiples. See, as we know that the multiples of 12 starts from 12, and the multiples of 4 starts from 4. So I'm selecting C. Here 12 is the common multiple. I'm writing aside. And one more C, 24. Writing myself. And so on. What the point? So here see 12 comma 24. These two are there will be more multiples also. But see, these two I am taking now. 12 comma 24 means common multiples of 4 and 12 are started from 12 and infinity n. Okay, so here in these two numbers are divisible by these two numbers, each of two numbers. So 12 is divisible by 12 and 24 is also divisible by 12, and 12 is divisible by 4 and 24 also divisible by 4. So these two numbers divisible by each of given numbers. So in these we need to take only the least one. So 12 is the exact uh, sum of given numbers. So 12 is the answer. So like this, we need to find the LCM, least common multiple. I think you got an idea about LCM. What is LCM? Exact definition of LCM. Again, I'm going to reveal the definition of LCM. The least natural number which is divisible by each of given numbers, or the least natural number which is multiple of given number, each of given number. Got the point? Okay, now let's go to the amazing techniques to find least common multiple. You are going to enjoy this lesson, right? Hi my dear friends and students, welcome to this lesson. In the previous lesson we have learned definition of what is exact definition of LCM. In this lesson we are going to learn the amazing techniques to find the least common multiple of the given numbers. Let's see how we can find LCM by using this amazing techniques. Let's see now. Technique 1, which is called M technique. M technique is nothing but M for multiple. M for multiple. So how we can apply this technique to find LCM? Let us see now. So let us take one example. That is, I'm taking see LCM of 6 comma 12. LCM of 6 comma 12. We need to select the biggest number of the given numbers. So in this C, easily we can find out the biggest number of is 12. So 12 is the biggest number. The second step is we need to see that we need to compare the biggest number with other numbers. How we can compare the biggest number with other? If the biggest number is a multiple of 6, then directly and you can write your ultimate answer as 12, the biggest number. Complete the two steps. The first step, the biggest number, and the second step is we need to number the answer ultimate can write the biggest number. That's why the answer is for this problem is 12. Got the point? So as there are only two numbers, easily we have found the LCM of 6 comma 12. If there are three or more digits, does this technique apply to the next problem? Let's see now. Next problem. See, in the previous problem, we have taken only two numbers. In this problem, I am taking three numbers, 9, 18, and 36. Same, we need to apply the same steps here, my dear students. See, in this, as the first step, we need to see the biggest number. What is the biggest number here? So easily we can select that 36. Only there are only 9, 18, 36. Among this, only 36 is the biggest number. The biggest number. So B I am writing as the biggest. Okay. So 36. And the second step, we need to see that whether the biggest number is multiple of others. Same. However, we have compared with the 6 with the 12. Same here, we need to compare the 9 and 18 36. Okay. So let's see the 9. We can cancel 36 with the 9. 36 goes 9 table in 4 times. So 9 for the 36. 9 ones are 9. 9 to the 18. 9 to the 27. 9 for 36. So 36 is the multiple of 9. And let's go to the 18. And easily we can understand twice of 18 is 36. So nothing but 18 twice is equal to 36. 18 twos are 36. So that's why 36 is also multiple of 18. Therefore, as 36 is multiple of 9 and 18 both, so here we can understand that 36 is our answer, as it is the multiple of the both other numbers. Got the point? What is the LCM of 9, 18, 36? 36. Got the point? Okay. Hi, my dear friends. Welcome to Technique 2. So, Technique 2 is nothing but co-prime method. Means if there are co-primes in the given problem, then what would be the technique to find the LCM? Let us see now. Okay. So before that, we need to see that what is co-prime. Got the point? What is the definition of co-prime? Okay. Let's see the definition of co-prime. See, my dear friends, if you take the two numbers, if they don't have any other factor except one as their common factor, then we can consider them as co-prime. For example, I'm taking an example now. See, I'm taking 4 comma 9. 4 comma 9. So let us see the factors of 4 comma 9. The factor of 4 is 1 and 2 and also 4. And factors of 9 are 1 and 3 and also 9. So just compare those factors. Let us select, let us take only the common factor now. The common factor only, we can see that that is only 1. Means the 4 comma 9 have common factor that is only 1. So that these 4 comma 9 are the coprimes. I think you have got an idea about coprimes now. Like that, we can take 3 comma 4. Every two consecutive numbers are coprimes only. Why? Because they have no common factor except 1. Got the point? See, in the given problem, if there is need of finding LCM of the coprimes, then what would be the technique? Let's see now. Okay. Let's see one example of finding the LCM. So LCM of 11 comma 13. Let's see. So 11 comma 13. So 11 and 13 are, so they don't have any common factor as they're odd numbers, and also moreover they are prime numbers. So they don't have any common factors except 1. That's why we can define them as coprimes now. So that's why whenever there are coprimes, their LCM is nothing but the product of given numbers. Simples. Got the point? So these LCM is, so LCM of the 11 and 13 is only just multiply them. 11 into 13. Nothing but 11 13s are how much? So 143. So 143. The product of 11 and 13 is just to multiply and just see that 13 and 11. So we can check here 39, 11. There is one shortcut method also to find the any number with 11. In the next class, next upcoming class, I am going to explain that secret also. Okay, you can learn that. But now I am revealing only the general method only. 11 threes, 33s, and 11 ones, 11, 11 plus 3, 14. So 143. 143 is the LCM of 11 and 13. So no doubt, my dear students, whenever there are two co-primes, just multiply them and write is answer as an LCM. For the point. So let's go to the next problem. If there are three co-primes, then what we have? Same. If there are three co-primes also same, we can multiply the three numbers to get their LCM. Okay, let's see that. Example 2. See, in the previous example, we have taken the only the two digits, sorry, two numbers. Now I am taking the three numbers. By so their LCM is, so just multiply them. 21 into 8 into 7. Just multiply them. So 21 8s are, so 8 1 8, 8 2 is 16. And again just multiply with 7. 7 8 is 56. 7 6 are 42. 42 plus 5, 47. And 7 1 is 7. 7 plus 4, 11. So what is the answer, my dear friends? So the answer is 1176, means 1176 is that LCM. That's simple. Just multiply them directly. You can write as LCM. No need of the synthesis division method. Okay. So that's all for this lesson. Let's go to the technique 3. Hi, my dear students. So, welcome to this lesson. In the previous lesson, we have learned the technique 2 and technique 1. So, in this lesson, we are going to learn the technique 3. Let's go into that. So, the technique 3 is nothing but miscellaneous method. So, what is the miscellaneous method? Let us see now. So, by taking the example, in the example 1, the miscellaneous method, see how we can find the miscellaneous method now. Yeah, 3, 21 and 2, there are the three numbers are given in the problem. We need to find their LCM. In the same method, my dear friends, the first we need to take the biggest number of this. The 21 is the biggest number, and we need to check whether the given all other numbers are factors of 21 or not. Or 21 is a multiple of other numbers or not, we need to check it. So here see, by 3, by dividing with 3, we get the 0 as a reminder. So 3 is a factor, only just the other factors. Which are the factors? As 20, as 2 is not a factor here, so directly we can multiply with 2. And moreover, before multiplying, we need to see that the whatever the non-factor thing is here, the non-factor thing, whether it is co-prime or not, also we need to see that. If it is co-prime, if it is co-prime, then we need to multiply that. If it is not a co-prime, then there will be another process in the example 3 I'm going to explain now. So in this process, as this is a co-prime, directly I multiply to get the LCM. Now 21 to is equal to 42. The 42 is the ultimate answer. So let's go to the next problem now. So in the example 2, LCM of 7, 14, 13. In the same process, here 14 is the biggest number. Easily you can say that 14 is the biggest number, and the 7 is the factor. That's why 7 is I'm cutting down, and the rest of the number is 13. As 13 is the co-prime of 14, so that's why directly I am multiplying 14 into 13. So by multiplying this, see 13 fours are 52, and that is 1 to 13. 13 plus 5, 18. So 182 is the LCM of 7, 14, 13. And let's go to the next problem now. In the example 3, so in the example 3, say we need to find the LCM of 8, 12, 16, and 4. So in this, see the same process, the first we need to see that the biggest number, that is 16. So, and we need to compare the other all numbers with 16, whether they are factors or not. So here 8 is the factor, so I'm cutting this factor, and 12 is not a factor, so I'm keeping safe. And 4 is a factor, I'm cutting down. So the rest thing is only 12. So, and also we need to check it whether the 16, 12 are co-primes or not. So absolutely 16, 12 are not co-primes. Why? Because they have the common factors other than 1. So 4 is a common factor. So other than 1, and 2 is also common factor. That's why they are not co-primes. So in this process, what do you see? So we need to multiply the 16 with the least numbers to get the least common factors of, sorry, least common multiples of 16 and 12. So first I am taking the 2. So 16 twos are 32. And whatever we got here, and we need to set that whether it is a multiple of 12 or not, we need to see this. So absolutely 32 is not a multiple of 12. So we need to trial with another number. So let us take 3. 16 threes are 48. 16 threes are 48. So by trialing with 3, we got the 48, and also we need to check that whether it is a multiple of 12 or not. Yes, exactly. It is a multiple of 12. 12 fours are 48. So as 48 is the multiple of 16, and 48 is the multiple of 12, as it is least common multiple of 16 and 12. So the final answer is the 48 is the least common multiple of the given four numbers, 8, 12, 16, and 4. These are the three techniques were awesome techniques which are wherever we have never seen. By using these techniques, you can save the time in the all the competitive examination. I think these techniques may help you to enlarge your knowledge. Thank you. Thank you very much.